Welcome, Noura. Nice to have you on as well. And Azam, thank you for starting the recording. So, as you guys know, the video meeting is being recorded. Now, today we're going to do a couple of things. So, first of all, I'll speak a little bit about the research task again. So, I understand some of you guys were traveling, and then some people had exams. But start going through that research task. Start shortlisting the papers that you want to study. Share the papers with us so that we let you know that whether you're heading in the right direction or not. And then you can every week show us some progress, talk about the papers that you read, give us a synopsis on what's happening over there, how the research is going, and so on and so forth. So this is number one, and this is very important because going forward, now we're in the second half of the training cohort, and it's very important that we start getting feedback from you guys from a research perspective. Number two, as you guys saw in the group, I shared the new report, the diagnostic report as well. So you saw the additions to it, which was the PET amyloid based quantification. So basically, what is going on is, as I've told you many times earlier before, that Alzheimer's disease diagnosis is not easy. The first step is doctor orders a MRI. After the MRI, the doctors first sees whether there's potential for the client and eligibility to go for the PET amyloid or PET tau exam. And then that exam is expensive and invasive. It involves the injection of a radioactive tracer in the bloodstream, which travels all the way up to the brain, and then PET imaging is done. Now, what our model recently, thanks to Azam's developmental efforts, what the model has started doing is that you give the model a simple MRI, and it's going to start predicting the amyloid PET result. That is a very major breakthrough, and accuracy rate right now is 85%, and it's going to go higher, inshallah. And this training session is going to be based around that. Thank you, Khalud, and welcome, Hasib. Welcome to the training session as well. And Mr. Azam, let me turn it over to you so you can start the presentation, please. Thank you.
Okay. Okay. Are you seeing my screen?
Yes, I can see it. Thank you.
So fine. First of all, basically, the today lecture is based upon the MRI based PET amyloid and tau synthesization and quantification. In previous lectures, we taught about different things about AI like Ulama server and some agentic models and some tasks regarding to the VLM, how the VLM is working on and how we train over VLM and the top VLM on the available in the market like NetGemma, Netflip, and other variants of ChatGPT and Gemini. Now, basically, there is very hot topic that how we analyze the thing. Basically, in the past, there are a lot of models are available and people are making development on different diseases uh, in neurology, Alzheimer, Parkinson's, and brain tumor and other things. Uh, but and further that they explain such thing through explanation AI. Nowadays, there is hot topic. The synthesize means generation of the images, some other image like MRIs, CT scan, to PET amyloid and PET tau regeneration of images, and the building of VLMs and other things. And the second thing is that how to quantify these things. Quantify means, first of all, I show you a diagram. As you see that this is an animated GIF of MRI based PET amyloid synthesization. Synthesization is generation of images. The idea is that uh, the MRI is easily available in all the regions and all the hospitals because it's not very old technology. The latest thing is fMRI and other machines, but the MRI is easily available in every regions like Asia and other developed countries. As you see that there are three views of the MRIs. The first line is the anatomical scan. Basically, these are the MRI scans and the MRI scans of the brain and the three different posture of the brain like axial posture, the sagittal posture and coronal. And basically, in view that x-axis view, y-axis view, and the z-axis view. And you see that basically the diagram shows that there are two data sets. The internal data sets is the data sets which we are collected from different sources like ADNI, A4, OSIS, and other sources. And the external data set is a data set which we are selected from specific some private hospital, private organization data for the cross sectional verification and for the testing purpose. And you see that we take MRI, and after the taking MRI, the MRI goes to the model. The model is normally the transformer and CNN based model, and the model convert that in PET amyloid. You see that to SVR. Basically, the SVR is the standard uptake value ratio, which is calculated from the PET amyloid tracer. And you see that this image, the first image in the line is the image which is already a true image of the person, which take the MRI. And the second image is the prediction. The model predict that. The idea is that if you have a MRI, then we train a model for the pair of the MRI and PET amyloid. And after giving as an input of MRI, the MRI generates the PET amyloid image, the last image. And this is the idea. And this idea is a very top line idea because the PET amyloid is too much costly and it's not of the range of every person. But the MRI test is not too much costly, around about 100 $200, and the PET amyloid cost is more than $1,000, and it's too much high. Now to move forward, that basically this is a training architecture of the model. How we train that? You see that VAE mean which vision encoder and encoder model. Basically, this is a computer vision model, and the diagram shows that first we train the MRI on VAE training, and secondly, we also train that the SVR VA training, and now we move to our main model, training model, and after that the infrastructure. Basically, this is high life diagram. The basic idea shows that how the things are working architecturally in the background, but at such phase we do not understand that how the things are doing now. Now we move forward to second. Basically,
Atma, I'm just going to speak a little bit. If you can move one slide back towards the architecture. Thank you. Okay, guys, so keep in mind how we taught you what our model is doing. So we are training our AI model on pairs of data. Okay, so the pair means that from the same patient you took a MRI, and then from the same patient you took a PET scan, whether it was amyloid or tau. So that is the pair. Okay, so first we gave the model MRIs and said, okay, this MRI belonged to a patient XYZ who had early onset of Alzheimer's or MCI or mild aggressive, whatever the stage was. So we taught the model this is what the Alzheimer's patient looks like. Okay. Then in the next phase, we gave the model from the same patient, this time tau. And we said, okay, this is the same patient that you and now a patient with early onset of Alzheimer's looks like. Now PET scan for amyloid or same patient and to the same category. Okay, so the model is then learning. It is learning. It learns. Okay, you know what? For this category of disease, this is what the MRI, this is what the PET scan looks like. So this is what the flow diagram is essentially trying to walk you through. Sorry, I just lost my connection a little bit.
There is an
Can you?
internet voice issue. I'm inviting inside.
Okay,
I
back.
think there is some
So
distortion.
okay, so Azam, I will let you continue. Can you hear me now?
Yeah, yeah, I hear you.
Okay, perfect. So basically, we're training our model on pairs of data, like I said. So in the first part, you see the MRI training. In the second part, you see the PET amyloid training, which is represented by the SUVR value over there, which it generates, the standard uptake ratio. And then obviously the next steps, which is control net training and the inference process, which leads to the interpretation. So it is a step-by-step process. First, we are teaching it to learn what the MRI looks like. Then we teach it what the PET amyloid looks like. And then we ask it to start learning and predicting from the input of a simple MRI what the corresponding amyloid PET scan would look like. So that's how it makes the inference, and that's how it makes the prediction. Back to you, Azam. Thank you.
Now I move forward to the next slide. We prepared um, a report regarding taking MRI, and after that some making some gradient cam algorithm and segmentation features. We determined that there are two areas on how the process of the quantifications is done. When we convert the MRI to the PET amyloid, your PET tau image. Now further is that how we quantify this is. Quantification means first of all, we take the segmentation area, which area we take that, and after the taking such area, we quantify. Quantify means the region of the area calculations, like the calculations of SUVR mean, and the other thing is Z-score, and the other thing is that the centroid ratio. These are basically the all the neurological calculation things which the doctors are calculate and analysis that the how the level of disease and how the stage of the disease for the concerned patient. First of all, you see that there is the area of the reference area. Reference area shows that which area we took that and we take from the quantification. Basically, this is the front view of the brain, and you see that the first thing is that whole cerebellum. The whole cerebellum is the area which is fluid area. Basically, if you know about the MRI, basically the MRI have three area. First area is the white uh, cell area, and the second is the gray area, and the third area is cerebellum area. Basically, the cerebral area is CSF area. The whole CSF area is that, and after that, you see that the second arrows in the cerebral gray matter. Basically, the two small angles shows that the two arrows. Basically, these arrows are show that the cerebral gray matter, and the third thing is the circular thing, which is the pawn area. Basically, these are all the definitions regarding the neurosurgeon. But the idea is that how the things are going to input take the model and how the models perform that. Basically, the majority of the class based upon both the people. Some people are also working in the neuric science, and some are working on the AI field. But the basic fields of both of the people regarding the medical science, and the medical student best know that how the things are working. And now the second area is that the bluish area. You see that this is a target region. Which regions are we target that for the quantification? In first figure, we target that the sensory motor, and the parietal area and the posture pancreas area. And if the last image, we take the frontal, anterior, lateral, and occipital. These are basically the areas and the neurological person must know that the things. And that's why Sir Ahmed, giving you uh, the research tasks. You people research that the things, and after if somebody have researched some paper, they better know the thing. And the people who are not due to the age vacations and some other issues like examination issues in your institutions, they I advise that they review the things in such pattern. First of all, they study upon that the synthesizes, which papers give you the synthesizes area and which papers give you the quantification, and in between some paper also give you the idea about the segmentation. The many people also working on free server. Free server is a library which gives you the best quantification about brain and other diseases. Now we move forward that basically this is the report. The report based upon that the previous report, previous thing. First of all, in the model calculate that the reference area and took that the reference area the target gen, and the target gen are the six ROIs. ROIs mean region of interest. Basically, we take the region of interest, and after that, the region of interest, we calculate the values. First value belongs to SUVR. Basically, SUVR standard uptake value ratio, and this ratio is belong to cerebellum area. And in further slides, we also give you the idea of the scaling, how this scales belongs to. If in roughly, if your SUVR cerebellum ratio is below than 1, it's mean you are in the good position. The uptake is not in a serious level, it's less serious level. But if your value is moves to one, it's mean that you are in crucial level. Similarly, the values of the diabetic person HbA1c value is goes to 6.0, it's mean that the person is moving to the diabetic condition. Similarly, the Z-score, basically Z-score is also a probabilitical analysis which based on the SUVR value. The main value is the SUVR value, and the second value is CL. CL belong to centroid value, and these are the figures. And the next two values are the uh, alpha means the positive thing of the PET amyloid. AB load, basically the it calculate on the if the ratio is positive, then how much positivity of the ratio, and is based on that the region of the PET amyloid amount. And second thing is also the indexing. Now, basically, these are the four variants which are in medical terms. You can say that these are the four biotracers which are used for PET amyloid test. Uh, I am utilizing the fluorobutafil. Basically, the fluorobutafil is the version which is easily available, and it's not too much costly. And the first variant you see that flutometamol, and the second is fluorobutafin, and the third is fluorobutafir, and the last is the fluorotaupitathin. Basically, the last version is belongs to taupat. Basically, it's not a amyloid version, but the rest of the three versions belongs to the uh, and the diagram shows that you see that the first diagram, the left hand side, you see that uh, in the cursor is going, you see that the first diagram shows the negativity. Negativity means that the yellowish area shows that the amyloid uh, percentage amyloid in the brain, and you see that the negative ratio of the yellowish area is too much come, and the bluish area show that the negativity. If you see that the also a marker is available, the positive thing color is reddish and yellowish, and you see that the second line, you see that the major area is positive. It means that the amyloid ratio of protein is too much high, and the bluish area show that there's too much low ratio for the amyloid. And similarly, the other diagram shows that basic idea is show you people is that how the things are working, and how first of all you understand that the thing, then you predict, and then you analyze some reports. Now I am moving forward. Basically, this is the scale for you people, how these things are. You see
Mr.
that the
Azam,
quantification.
sorry, Mr. Azam, sorry to cut you before you move forward. Can you move back one slide, please? I'd like to ask the students
Yeah,
a question. Okay, so the students who are
yeah,
attending
yeah.
the lecture, who are on the call right now, so I have a question for you. Can anyone answer my question, which is, what is the unique selling proposition? The unique selling proposition means that what is the X factor in the solution that we are showing you in this slide and the previous slide and this entire slide deck? What is the X factor? Can someone explain to me, please? Okay,
Please
so
say
I'm
some words about that. I think that it's not a rocket science. You see that I am
yeah,
also telling that the
yeah,
MRI is
mm,
just one two lines. The
yes,
MRI is very easily available, and this is too much cheaper. But the second thing is PET amyloid and PET tau. Its test is too much high. If
yeah,
you have a program and you give the input of MRI, which is easily available, and after that you generate the images approximately 80 to 90% resemble that the original ground truth images, and doctor analysis that the level of the disease, I think, is a gold standard and in cheaper cost. This is basically the X factor of the thing.
Sorry.
uh, yes, 100%, Azam. Thank you. Khalud, is that you? Go ahead, please.
No, it's me, Nora. Hi, how are you, everyone?
I'm pretty good, thank you. Please go ahead.
Sorry, Mr. Azam. Mr. Azam. I'm not sure if that's
Yeah.
how you pronounce your name. So basically, the MRI, you're saying that the program can avoid the use of relatively more expensive imaging, such as PET amyloid, by the MRI by itself.
Yeah,
Okay,
yeah.
I'm gonna answer that. Yes, essentially. So what happens is you give our model the MRI, and it will give you this output which you see on your screen, and this will
Yes,
show
image.
you all the amyloid PET status and the PET tau status. So
Mhm.
basically, we are giving you all the imaging and the results that otherwise the amyloid PET scan would have given you. So instead
Yeah.
of spending 12,000 or 13,000 reals, 12,500 reals, the cost of this exam is the PET scan. We are only spending 700 reals, which is the
Okay.
cost of the MRI.
So you cut the expenses in more than half.
Another one thing
Yes.
in other that
Yeah.
if you take the PET amyloid exam, the exam give you only the figures of the PET amyloid. It does not give that calculate that the SUVR value, Z score, centroid. These values are not calculated that. These values are also calculate some other software taking
Okay,
that
so
figure.
you're saying it provides even more information
Yeah,
Yeah, yeah,
it
yeah,
as
yeah.
provides
compared to
a
PET
lot more
amyloid.
yeah, a lot more information,
Oh,
and all of this from the simple MRI. So you don't need to go for the PET scan. With the
oh,
simple MRI, we'll give you everything, including the imaging and the results and the quantification and the calculations and the SUVR score and everything.
okay, great. Thank you. I just wanted to make
And
sure
one
I
thing is
understood.
one other thing is that
Yes.
If you take in some research paper, I am also studied that if you take a PET amyloid session, the next session you give approximately 6 to 9 months. You do not take that the random session of that because the tracer is injected in your brain. But in our case, if you are taking a MRI and you see that after that you take some medication and you want that you repeat your MRI, you after repeat that the MRI after the 2 or 3 months, and you take such MRI and give such MRI to such software or some other software which are also providing you the synthesis and quantification. You have a chance that how much progress you go that. But in case of the you move to simple on the PET amyloid or PET tau series, you take after the 9 months. And because and sometimes doctors suggest that you after the 1 year the next test is conducted that due to the tracer radioactivity and other things.
Yes, you can't do the tests again and again. So that's a very, very good, legitimate point you made, Mr. Azam. Khulud, you wanted to say something as well. You had your hand up. Please go ahead.
Yeah, I was just going to say the exact same thing, that the X factor is basically cutting the costs of a PET scan using a simple MRI. And it also
Yes, yes,
provides
yeah,
like,
yeah, yes.
yeah,
Cutting the cost, yes, and it provides you this with our model provides you with the input of a simple MRI, everything that a amyloid PET scan would have given you, and
yeah,
more, and the calculations as well.
quantitative
Yes,
amyloid
quantitative.
measurement.
Yeah,
Yeah,
yes, 100%, 100%. Thanks. Back to you, Mr. Azam. Thank you.
Now I move forward that basically this is the quantification methods. Different researcher, the basic two methods are the SUVR and the centroid scaling. The SUVR is the top of the line model. As you see that the regional area of interest, basically the ROI represent that the regional area of interest, standardized uptake value ratio that is based on patient tissue uptake and demographic and dose. Basically, when we calculate the thing, we also take some other reports of the doctor. Demographic reports mean the other thing like your different tests, your MMSC test, your blood sugar, your blood pressure, and other things. These are also affecting on the brain. If you have a high blood pressure, it symptoms your brain, and also if you are continuously in such condition, it's also affecting your brain. And these things are also included with the calculation of SUVR. And the second thing is centroid scaling. Basically, the centroid scaling is also global SUR calculations. These are also computed for the reference area. Basically, the reference and regional area, these areas are the two areas which we calculate such things. In the previous diagram, I also showed you that which is the region area, which is the target area, and which is the and I also repeat that there are three areas. First area is the synthesizing area. It's mean you generate the images for MRI through synthesize process. And the second thing is the segmentation of your PET amyloid image. And the last thing is that the quantification. And after the quantification, you map the things through the quantification scaling. Basically, these are the pattern and stages. You research that different people give you the idea about only the SUVR. Some people paper give you the idea of synthesization. Some paper give you the more than two methods, and I cannot find a single paper who covered all the three things, because these things are too much research are involved on all the things. And basically this is target for you people. You research that, and you see that in the last side of the image we also show you the amyloid burden centroid scale. Basically the scale is that if you are less than 30, it's mean yes, you are in the negative condition. In the right scale you see that 0 to 10 is a negative amyloid burden, and if you are to 10 to 30, it's mean yeah, you are pre-conditioned. Just like the pre-diabetic condition, you are intermediate amyloid burden. And if you are greater than 30 centroid ratio in your brain, it's mean that you have the positive amyloid burden, and this positive thing moves to you for Alzheimer disease and Alzheimer early stage to some other stages like moderate stage and some and the last stage of the Alzheimer. Now, basically, these are the some reports we analysis some different research things, and also working for the generation further generation of such type reports. Basically these are the areas, uh, individually calculation of such areas for all the things. In our report, we calculate a aggregate volume of the SUVR, but you see that some people and some researches are also available for the calculations of the internal ROI regions. As you see that, this is very good report. As you see that, it takes five ROIs, and every ROIs the calculations of SUVR and Z score. Third thing, centroid is not calculated in this report. You also include that. And the other thing is that there are two regions. If you move forward, basically in the previous slides, you see that there are two areas. Basically, the two curves are two areas. This is the right area, and this is the left area. Both two areas are calculated in this report, the left area and right area. And after that, in the last, you see that the tracer also provide you the which tracer is used for the calculation, the fluoro beta fit, and also uh, provide you the mean of the every area. How you calculate the mean? You sum up all these SUVR and divide it by 5, and you have the value of 1.46. Similarly, you also calculate the centroid value. It's aggregate centroid value, but in report you also give the every area centroid value also give you in the report. Basically, the centroid value is the number of 100-point scale. In the last slide, you see that there is a 100-point scale. Basically, the scaling of the centroid value. The centroid value is necessary for the calculation of the Z score, because the Z score is not calculated without the calculation of centroid value, because the formula of the Z score is based upon the SUVR and the centroid value. And after the right hand, you see that we also calculate that the anatomical figure of the brain. Basically calculate the hippocampus ml value in the milliliter values. The hippocampus and other thing is cortex, superior cortex, and the last thing is also a very surprising thing for me, the hippocampus occupancy score. Basically this is provide you the shringness of the hippocampus. How's the level of the hippocampus is shrink that? Basically this is also a scale. 0.38 represent that which level of shrinkness is also a thing. And the other thing in the side, that the normative percentage, how much percentage the things are going down. Basically this is very good report. First thing, the images, condition of the images. But in such cases, they are not applying the pre-processing structure on such images. These are the very raw images, and after the raw images, you apply the grid gam method. But in you see that in over reports, we also apply that the pre-processing things and some clarity things. The things are clear that because when you print out such things that these things are not in a very good position for naked eye see naked eye, but these values shows that the reality. Now in the other report, basically this report is also based upon the radio tracer tau pitavir. You see that in tau pitavir there are a lot of things extra regarding the amyloid. But our idea is that we are first focus on the amyloid things, then we move forward to the tau thing because tau thing are too much complex, and also sometimes the tau tests are not easily available in every lab because these are the high level variant of the PET quantification and PET tracers. And similarly, all the things, the calculation is that.
Azam, I'm just going to add something over here. So, guys, just to recap, um, amyloid and tau, both of these are proteins that exist in the brain. Now, in a regular brain, what happens is the brain builds up these proteins and then breaks them down, builds them up and then breaks them down. That's the normal process. But for an Alzheimer's patient, what happens is that these proteins, amyloid or tau, they build up in the brain, but they are not broken down. So that's abnormal. That is not normal. So these proteins, when they build up, they start eating the brain. Okay. And that is what then causes Alzheimer's disease. Now, what does a PET scan for amyloid or tau? What does it do? It shows you the tracer, it travels all the way to your brain and it looks for the protein. It depends on the tracer that you use, whether you're using a tracer for amyloid or using a tracer for tau. So it will go and look for amyloid or protein in the brain, and then the tracer, if it finds it, then it will go and attach itself to it. Okay. So when you do the PET scan, it shows up as different colors in the scan. So that is how you know, number one, which area of the brain the amyloid or tau is in, and number two, how much of it is over there. Okay, so these are two things. So these diagrams that you're looking at, we are giving you these diagrams from a PET scan. So, sorry, from an MRI result. So from an MRI, our model is not only telling you how much protein there is, but it is also trying to tell you where the protein it is, which area is it concentrated in. So there's different areas of the brain. So think of it from that perspective that it's such an advanced AI model that even without the PET scan, it is giving you both things, the quantification of the protein and the location and the distribution of the protein. Because the distribution and concentration of the protein is a very important point. If it is present in a very critical area of the brain, it means that it will cause more damage. So you have to keep that in mind. Back to you, Mr. Azam.
Now, anyone have some question? If you are researching such thing that I believe that after um, some effort from me and Sir Ahmed, you are able that to further explore the things. And you people, first of all, for research, you select that the area, you know, those to all cover all the areas because you are beginners. And I also share you some papers for your reference and your research perspective. And after you learn that, the papers also give you also the reference of some other papers. These are the other informations, informatic papers for your search point of view. And I believe that in after 1 or 2 weeks, you have give some output regarding such
Yeah,
things.
100%, Azam. 100%. The students, I'd like you to go through different papers. Every paper will have 10, 15, 8, 10 papers listed in that as well in the bibliography. So those papers are also relevant. So one paper will help you find 10 more papers. and then go through the papers. Don't get overwhelmed that okay, it's too much data. Just focus on one area. If you're interested in this report that you see on the screen, just focus on this area, do some research, see whether it's about amyloid or tau, what these proteins are, what do you see on the screen. You can use so many resources. You can use even LLMs like DeepSeek. You can go and upload this report and say, give me a full analysis of this. It'll give you analysis, then you can study it, then you can talk about it. Look, the purpose of this training class is not only to give you guys knowledge about something, but it's also to give you confidence, public speaking confidence. Because I found that in Saudi Arabia, especially in my time at King Saud University with the students over there, I generally find the students in Saudi Arabia to be very shy. So I want you to speak, even if you speak like 5 minutes about something, I want you to speak freely and just focus on one area, do some research on it. Okay, so this is a mission for next week for you guys. So read a paper. You don't have to give me analysis for the full paper. You can just pick out one area, one report, one diagram, and then you come back in the next session and you speak about it for just 5 minutes. Each person speaks for like 3 or 4 or 5 minutes, just gives us a little bit information about it. Okay, this is what's going on, and that's it. That's how you'll start getting more confident in public speaking as well. Plus obviously your research will get better. So hopefully we'll listen to you more stuff from you guys from next week onwards, because for the this training cohort I think we've only got like 6 more sessions to go till the 12 sessions complete and we start giving out certificates. And to give out certificates, it's not just attendance that is mandatory. I also want you guys to contribute. So we don't have any assignments or anything, but these small assignments for research and stuff you have to focus on. There's no marks for it because we don't want to grade it, but we want to see your effort and input into it so that you learn something, and from you other people learn as well. So back to you, Mr. Azam.
Rightly, because I also say that the basically the purpose of the training is not make you people for programmer. Basically, the idea is that you have the confidence to interpret the thing of AI in the area of healthcare, specifically the neuro area. If you studied such thing from the research paper and you have simple such to display simple report some neurologist and you interpret such reports, the neurologist they have in the neurologist's mind have the idea is that the person have so much knowledge regarding the things, how the things are working and how these reports is generation. Basically, this is the idea and this is the confidence and the training purpose of the training. Um, I am explaining you the all the things in just like 30 to 40 minutes, but in the back, I am continuously researching from 3 to 4 months for understand that how the things are doing that and how we can develop the things and how, and still I am researching further more and more for the generation or other good reports. Basically, this is the confidence and this is the idea we are also provide you people. And regarding that, we are also interpret you the other things regarding the AI. In the last lecture, I am also giving you some lecture about the Ulama server. Basically, Ulama is the server which you run the LLMs and VLMs model locally in your machines. And I believe I also give you some cheat sheets and reference of the cheat sheets of the commands, how you run that Ulama, how you install that the Ulama. But due to some your commitments and other things, um, but I believe that when you get uh, put some efforts and you grab something, you put some extra efforts. You give some time from your routine times, and I believe that if you give only just 1 hour to 2 hours to study such things, And after the week, you grasp one or 2 points surely. But if you want that in one day, I am cooking, taking 10 to 12 hours and grasp all the things, it's not possible because your mind is not mapping the things um due to some tiredness and due to some mind capability. Because these things are also facing me in the earlier regarding the AI field and other fields of life, because every person has a social life and other commitments, but you must design a schedule how you sometimes you miss 1 or 2 days, but you do not make a routine that you take all the things in 1 week task in one day. It's not possible for nothing for a person, even that the person is too much professional, because the mind is not mapping. That's the idea. Now I move forward to our previous lecture. Basically, this is the Ulama server architecture, and I am basically just 5 to 10 minutes for the recall of the Ulama server and the persons who are not installing the Ulama server. I must prefer that if you are moving to the AI, it's a good thing that you install the thing in the local machine. If you are not installed such thing in your local machine, you also move to our machine, Neuro-Cognitive machine, and you put some command on that. Ulama is already installed on that, and you run the commands and uh, play that how the things are. You give the input and what the response of the output. Basically, the all the things are the practical things. These slides are giving you the idea, but the at the end the thing is practical. Now you see that first of in this architecture, we have the Ulama model. First of all, the Ulama version and Ulama model interact the Python application, and the Python applications moves to different type of APIs like Gmail API, and Gmail moves to Gmail server and give you the response. Similarly, the user input and user input takes some gives some output to the Python application. This is basically the architecture, and basically this is the installations link where the available. You just give on the Google and type that the Ulama download. You have some screen, and also screen you have some the URL. Basically this is the, if you type such URL for your DOS prompt, you give the some command informations. Yeah, you just I also give the link of the cheat sheet. Basically this is the link of the cheat sheet where all the commands of the Llama is also available. And after that, basically this is the basic commands how to start the Llama server. Basically Llama start, and after start you also give the of these both command are similar command. You give the Ulama start command and you give the Ulama serve, both are behave like similar that. And after that you check that your Ulama is running, you give the Ulama ps and check the logs and other thing. And after that, when you take the list of the Ulama, which models are locally available in your site, you give you the Ulama basically list. And after that you remove the model and you copy the model, so on that. And basically this is the thing that how we take the local model to remote. This is the other thing. And in the other lecture I also give you the uh, now I move forward over server machine and you give you some demonstration.
Adam, I think our 1 hour is nearly up. Let's
Okay.
let's do the demo
Okay.
next time, inshallah, because I think
Uh-huh.
we don't want to overload the students as well.
Okay.
So
Okay. Okay.
I
Okay.
think Ulama, we can focus on the next lecture. Please
Okay. Okay.
share the PDF or the slide deck in the group as well. And once the
Uh,
recording, you can do over the weekend,
okay.
so
Fine.
that everyone can take a look at it. And thank you guys, everyone, for joining in. Again, today, I think, marks the first half of our training course. Now it's the second half, which is going to start from next week. So I'd like all of you guys to participate like you usually do. I'd like to thank you, especially Maria and Haifa, Khulud, Dalia, Hasib. You guys come every time. There's a lot of students who have scheduling problems and they watch the videos and they send me questions throughout the week as well. So thank you for those students too. I know you guys are working hard and you've got your exams and everything as well, but this last 6 weeks, we have to focus on 100%. We have to focus on the research task. So you have to go through the papers, like I said, and Mr. Azam was telling you. Don't pressurize yourself. Look for something you have an interest in, pick out that section, read that section, interpret that section, use DeepSeek, LLMs, search, research, and then tell us about what you're doing. So I'd like each and every one of you to speak at the next section next Friday, inshallah, for 3 or 4 minutes. You can speak. So it'll be good, inshallah. And thank you again, Mr. Azam, for your insights and your time. And inshallah, I will see you guys next week. Thank you. Khuda Hafiz.
Thank you. Allah Hafiz.
Thank you all.